So let's take a look at this question together. It says that we have two hoses, one 20 millimeters and one 15 in diameter, and they're connected one behind another to a faucet. So we have a 20 millimeter, and then we go down to a 15 millimeter. My picture is not to length. And at the open end, so at this end right here, we're going to get the water to measure 10 liters per minute coming out. And we want to know where in the pipe does the water flow the fastest. Well, if we know that there's 10 liters per minute flowing out, that means to continue that flow, there had to be 10 liters per minute flowing in from the faucet. If there's 10 liters per minute flowing into it, the amount of volume that can flow through this pipe is a large volume for a small area or a small length. So what's going to happen is that we're going to invoke the continuity equation that says the same amount of liquid flows through both parts. But since the particles that are sitting up over here and the ones that are down here are going to get pushed in together, we're going to have to flow all this in. What's going to happen is that this area right here is going to have a higher velocity than the velocity over here. So the velocity in 1, which moves in that direction, is going to be a smaller value than the velocity in 2. And this is because we're going to have the same flux, the volume per time. The volume of water per time has to be the same. And since this volume right here, say we look at this volume right there, that same volume is going to have slightly different dimensions later on. It's going to be a much longer volume because this is a wider, this is going to be narrower but taller or longer. So it's going to have the same volume in the same amount of time. And in order for us to move this whole block through, compared to that little block going through, this block has to move at a much faster rate than that block. So the water flows the fastest through the 15 millimeter pipe.